Hello and welcome to my video lesson 5.3 on representing relations. So we have a few different relations here, two different examples that we're going to look at. And basically there are different ways that we can represent these relations. We have words, so we can have a word problem. We can have an equation, table of values, ordered pairs, mapping diagrams, and graphs. So we're going to do all of those down here for the first example. And then you guys are going to try it out for the second example. If you already know this from class, then I would recommend just trying this out right away, pausing the video yourself, trying this out, and then seeing if you get it correct. Okay, example number 1. So we have the profit gained from a lemonade stand depends on the number of cups sold. If every cup generates 50 cents in profit, that should put that in all of the different methods above. That is the wrong word. I don't even think put that is the right word, but whatever. Doesn't matter. We're going to move forward. Okay, so I find it easiest to do a table of values first. You can do this differently, but I think if we look at the number of cups, that would be our manipulative variable, our independent variable, or our x values. And if we look at the amount of profit, that would be our responding variable or the dependent variable. Depends on the number of cups. Okay, so every cup generates 50 cents in profit. So you can do this in dollars or in cents. I'm doing it in dollars. But if we have 0 cups, we have 0 profit. If we have 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, well, we have $0.5. We have $1.00. We have $1.5. We have $2.00. And we have $2.50. So we have all of these different profits depending on the amount of cups that we have sold. Okay, so now if we look at the ordered pairs, how would we write this down? Well, ordered pairs always go x comma y. So it has to be like that. It has to be x comma y. So here is our set of ordered pairs. Okay, I'm going to do it so that it's a little bit more clean instead of having all those extra zeros. I'm just doing it this way to clean it up, but feel free to write it in such a way that the dollar amounts, the dollar amounts make sense or look good or whatever. All right, yeah, that is all of the different items in our table of values. Oh, and we should go back to the equation now. So these are a few skills that you maybe remember from grade 9. If not, I highly recommend going back and watching one of those videos. But basically, you can tell that from here to here, we are going up by 0.5 every time. And here we're going up by 1. So this is actually going to give us our rise over run. This is the 0.5 of a rise over 1. So this is actually going to be 1/2. So if we make an equation, we can do it a few different ways. We could use 0.5 or we could use a 1/2. I'm going to use the profit is P, and then I'll do 1/2 C. So that's going to be our equation here. If you could have also done P equals 0.5 C, that also works. Okay, but notice our rise and our run, because we're adding both and those are the different values, that's where we're getting our slope from. This is actually our slope. And we'll look at that a little bit more in future videos, but that's what's giving us this number. Okay, remember y equals mx plus b. this is our slope, our m. And where does the b come from? Well, actually, the b comes from the original value when x is 0. So the y-intercept, which is when x equals 0. So that's why that's 0 in this question. Okay, let's continue on. We have an equation, we have a table of values, and the ordered pairs. Let's look at a mapping diagram. I wonder if we can do that without wrecking anything. I'm going to do it because I want a little bit more space there. Okay, so a mapping diagram is going to look like this. Basically, it looks like a table of values, except that you go and write it down top to bottom, and you put the whole thing in brackets. So I'm just going to, again, write it out like this to keep it a little bit neater. Okay, and I'm not going to go to, well, okay, I should go to 5 just because we have the data in the table of values. But I just don't want to use up the room, you know, for the graph. Okay. Okay, now that you have this, what you're going to do is you're going to relate everything. Now in this case, it's really easy. It just goes straight across. But notice that our x values are on the left, or independent variables on the left, and the dependent variables are on the right. And so it always points in the direction. So again, cause versus effect, as I talked about in the last video, or the video before that or whatever. But always cause then effect. Independent then dependent. Okay, let's make a graph of this data now. It's easiest if we look at the table of values to help us with the graph. Okay, so actually I'm going to give a little bit more room down here as well. Yep. Okay, so we have the profit in dollars. Okay, we have the number of cups sold. So I'm just going to write the title, cups versus profit. We always do y versus x. Okay, and so now what we're going to do is have 0 to 5 on the left-hand side. I think it goes 1, 2, 3, 4, 5. It does. How beautiful. Okay, now looking at the profit, we start at 0 and we go to 2.5. So 1, 2, yeah, 2.5. It's going to actually work out perfectly this time here. This happens to be an easy graph to make, which is nice. Okay, so it'll be 0, 0. It'll be, did I actually do it the wrong way around? I did do it the wrong way around. All right, we're going to start with the number of cups. Sold. On our x-axis, we're going to have the profit in dollars for the y-axis. So we always have it y versus x as the title. So profit versus, I'm just going to write cups. Okay. Now we're going to make the scale. And the scale works out pretty nicely in this case, going just to 5. Okay, and the profit also works out pretty nicely. So starting at 0, 0.5, 1, 1.5, 2, 2.5. So it works out pretty nicely. Now we're going to put our data on the graph. So 0, and then 1 to 0.5, 2 to 1, 3 to 1.5, 4 to 2, and 5 to 2.5. So there's our data. And again, we can't sell half a cup, so this is discrete data, so we actually have to leave it there. Okay, so you can see now that we've created an equation. There's a word description, there's a table of values, there's ordered pairs, mapping diagram, and a graph for this situation. Okay, now take a look at example number 2. Try this out yourself, and then see if you get the same answer that I do. All right, so here we have $150 per ticket at an Oilers game. Again, I think making a table of values is the easiest. So we're going to go with number of tickets. For our X values, we're going to go with the cost in dollars for our Y values. Okay, so if you purchased 0 tickets, 1 ticket, 2 ticket, 3 ticket, 4 ticket, 5 tickets. Actually, let's start at 1. 1, 2, 3, 4, 5, 6. Nope, because then it'll make it more ugly later. Yeah, whatever. It is what it is. Yeah, let's do it this way. Let's start at 0. 1, 2, 3, 4, 5. The cost will be 0 at first, then 150, then 300, then 450, then 600, and then 750. Okay, so if we look at the change, right? We think about the change in X and the change in Y. So the change in X is 1, change in Y is 150. So rise over run, well, it's just 150. Okay, so putting it into an equation, we go cost equals 150 times the number of tickets, and I'll just put capital T for tickets. Okay, if we think about ordered pairs, we would write 0, 0, 1, 150, 2, 300, 3, 450, 4, 600, and 5, 750. For mapping diagram, we're going to go like this, and we're going to write 0, 1, 2, 3, 4, 5. And then we're going to write 0, 150, 300, 400, 600, 450, 600, 750. So again, it is directly related, so it's just nice and straight across. They're not always going to be like that, but we're just keeping them simple. Okay, and then we're going to graph it. So again, best to look at your table of values to help you graph that. So we've got the cost, which is going to be in dollars. We have that going all the way up to 750. So I'm going to go all the way to 1,000 because it's just going to make it work out a little bit nicer. So this will be 500. This will be, well, we can just leave it like that for now. And then we'll go from 0 to 5. So it's 1, 2, 3, 4. Yep, that'll work. 1, 2, 3, 4, 5. And this is going to be the number of tickets. Yeah, so we have those axes now. Let's make sure that we put our main title on, which is always going to be cost which is our y value, are always our y value versus our x value. So cost versus tickets. And now we're going to put all the different points on. Again, having the actual table of values there would be helpful to see. So 0, 1 to 150, 2 to 300, 3 to, 3 to 450, 4 to 600, and then 5 to 750. And again, this is discrete data, as it is like number of tickets. You can't have half a ticket. So there it is. All right, I hope that this video helps you understand how to represent relations in a variety of different ways and how to understand all of those different types of ways. I hope this video helps you, and good luck.